Welcome to a wonderful weather, a drizzling weather outside, and let us have a very hot cup of DBMS. Let us sip, a sip by sip, it should be tasty. In this cool weather, let us have a very hot drink of DBMS, Database Management System. We are going to discuss about the topic relational model. The topic of today's class is the relational model. If we go with the recap of the previous class, we discussed about entities, attributes. What are entities? The entities are being identified by attributes. For example, student is an entity. How you are able to identify he as a student? He will be having a student number, name, mark 1, mark 2, total, average. All these are called attributes of entity student. You take employee. Employee is an entity. How you are able to identify that employee? Every employee is having employee number, name of employee, salary, he belongs to some department, some designation, blah, blah, blah. All these are called attributes of the entity set employee. Similarly, we go with the relations. Relations. One entity is related to another entity. For example, lecturer and student are related. Lecturer and student are related. Lecturer teaches the student. Teaches is a relation. That is a relation maintained between the lecturer and a student. Let me say a student got related to library. A student borrows books from library. So student is an entity, library is an entity. Student is an entity, library is an entity. And student borrows books from library. Borrows is a relation. Borrowing is a relation between student and library. Let me say student and examination. Student is an entity set and examination is an entity set. That is a different entity set. Student is having student number, name, mark 1, mark 2, total, which class, which section. All this comes to attributes of the student entity. Examination, examination name, examination date of examination, time of examination, room number, blah, blah. All this comes to attributes of the examination. Student answers examination. Answers is a relation. Answers, that is a web form. Anything which is in the web form, web form is nothing but it becomes an action verb. It becomes a relationship. A student is answering examination. Answering belongs to relation. The relation is always depicted in the form of a diamond. In the form of a diamond shape, we depict the relation, and entities are, as we discussed previously, entities are represented in the form of a rectangular box. Entities are depicted in the form of a rectangular box. For example, I am saying student is answering exam. Exam is an entity, student is an entity. Exam is an entity, student is an entity. Student answers examination. I am saying answers examination. Every student is identified by attributes. Attributes are depicted in elliptical forms. The attributes are depicted in elliptical forms. In the elliptical shapes, we represent attributes like student number, student name, his class. Similarly, for examination, I am depicting the attributes in the form of ellipse. Let me say examination number or whatever may be, the name of the examination, what examination, the date of examination, that becomes an attribute, the time of examination, that becomes attribute, and all this comes to. So, entities, attributes, and relations. Entities, attributes, and relations. This is what we discussed in our previous class. You can take n number of examples. Suppose you went for Raitu Bazaar to purchase some vegetables. You are a customer, and the opposite side is a vendor. A customer is interacting with vendor for purchasing. Customer purchases from vendor. Customer is an entity set, vendor is an entity set. So different customers are purchasing from different vendors, many to many relation. Different customers are purchasing from different vendors, many to many relation. That is nothing but cardinality, mapping cardinality. One to one relation, one to many relation, many to one relation, many to many relation. We discussed about that types of relation, which is called mapping cardinality. One to one relation, one to many relation, many to one relation, many to many relation, which comes under the mapping cardinality. That is nothing but the relations will be established between entities. Relations will be established between entities. Here the point to be remembered is sometimes what happens is On relation there will be some attributes. For example, here there is an entity. There is an entity employee. Let me say this is an entity employee. The employee is working for a department. Department is another entity. The employee is working for a department. This is the employee is working for a department. Fine. From date to date, let me say. The employee is working for a department from date to date. From date to date. From so and so date to. Employee is working for from so and so date to so and so date, we are saying. These fields, these attributes neither belong to employee nor belong to department. They belong to both. So here for the relationship, there are some attributes. For relationship, there are some attributes because the neither belongs to employee nor belongs to department. Because the employee worked for this department from date to date. Or in other words, for this department, particular employee served this department from date to date. These are the attributes which are required for both the employee as well as department. In such case, I will put that attribute to the relationship set. This is the relationship set. For the relationship set, I put the attributes from date to date. If these attributes are getting increased for the relationship set, if at all these attributes are getting increased for the relationship set, then instead of doing this better, you make it as a separate entity. This is employee entity. This is an employee entity. This is a relationship. The employee got related to department. So this is department. Now what I do is service. I'll take another entity. I put it as a service. This entity name I put it as a service or some name. I put it as a service. And for this service, I'll put the attribute from date to date and whatever may be. His achievement in this duration, the achievements in this duration or whatever may be. Here, instead of putting multiple attributes to the relationship set, then what we can do is we can make it as a separate entity, and for this separate entity you can put attributes. This is better than putting attributes on relationship set. That is nothing but relations versus entities. Relations versus entities. Attributes on relations, as we discussed just now. Attributes on relationship sets. There is a possibility of getting attributes on relationship set. This is called relationship set. For this relationship set, there is a possibility of getting attributes. That's what he says. Attributes on relations. Sometimes binary relations are much better than ternary relations. The binary relations are much better than ternary relations. We can express more details with the binary relation than ternary relation. Sometimes, not always. Sometimes we prefer to go with the binary relation, though it can be depicted in ternary relation. Employee department projects. Every employee is involved in project. Every employee got involved with some department. Every employee is working for some project. Every employee is working under some department. This particular relation, there is a relation between employee project. There is a relation between employee department. This particular relation can be shown with the ternary relation. It can be depicted with a ternary relation, and also it can be depicted well with binary relation. Either ternary relation or binary relation, it can be depicted. Situationally, depending upon the problem, either we choose the binary relation or we choose ternary relation to show the diagrams, ER diagrams. Aggregation versus ternary relation. Aggregation versus ternary relations. Aggregation, as you know well, we means we club entities and relations. Aggregation is nothing but we are clubbing entities and relations into a single unit. We are clubbing. This is called aggregation. Entities and relations are being clubbed together, and for this clubbed one, we establish a relation. For this clubbed one, we establish a relation like this. A relation, a entity got related to entire stuff. This entire stuff. Let me say this is entity 1, this is entity 2, this is entity 3. Entity 1 got related to 2 as well as 3. Once again I repeat, entity 1 got related to 2, entity 2 as well as entity 3. Then I can put these two clubbed together, and for this clubbed form, this is called aggregation. For this aggregation, I can establish a relation. This is called aggregation versus ternary relation. The same thing if I go with the ternary relation, the same thing if I put in the ternary form of ternary relation, you can write like this. Suppose this is the entity, this is another entity, this is another entity. Let me say entity 1, entity 2, this is another entity, this is another entity, this is entity 1. Let me say this is one entity, first entity, this is one entity. This entity got related to this entity got related to this entity, and these two entities are related this. You observe here more relations. In this diagram, you are drawing more relations. Entity 1 got related to entity 2. This is the relation. Entity 1 got related to entity 3. This is another relation. Entity 2 and 3 got related. Entity 2 and 3 got related. You observe here one relation, second relation, third relation. Instead of going this, more relations, better you can do this aggregation. 1 got related to these both, and hence what I done is second and third I put together, I clubbed. Second and third I clubbed. And 1 got related to this I am saying. This is called aggregation. This is all about our previous classes, recap of the previous classes. I hope, dear students, you got recollected the previous stuff. The reason why we are recapping the previous stuff is it is a human psychology if we forget the previous things. I'm sure that you had left the topics from your brain. So we recapped, we revised the previous topic. Now we are proceeding to the today's agenda, that is relational model. We'll discuss what is relational model, creating and modifying the relations, inserting into the relations, deleting from the relations, modifying the relations, integrity constraints, and specifying key constraints, foreign key constraints, super key, candidate key, and primary key. The outcome of today's class should be relational model, creating and modifying relations using SQL, structured query language, insertion into relation, deleting a tuple, modifying the relation, integrity constraints over relation, specifying key constraints, foreign key constraints, super key, candidate key, and primary key. We are going to discuss and primary key. We are going to discuss these topics in this class. Relational model. As you know pretty well, a relational model, it was developed by a person called Cord, stands for E.F. Cord. E.F. Cord. It was developed by a person called E.F. Cord, Cord rules, and he proposed some rules to store the data. And all those rules are called as the Cord rules. He defined 13 rules. And if any software follows these 13 rules, those rules are called Cord rules. He is called E.F. Cord. E.F. Cord. They are called as Cord rules. The 13 rules are called as Cord rules. Any software which satisfies these 13 rules are called as Cord rules, and they come under the relational model. It was developed in 1970s. All this stuff is being developed in 1970s. 70s. The relational model revolutionized the database field. Previously, you are having network model. Previously, you are having networking model, network model. Previously, you are having network model. And of course, you are having ER model. You are having semantic data models. You are having semi-structured data models. You are having object-oriented data models. You are having many data models. We discussed data models. The underlying structure of the database is called data model. You are having different data models. Out of different data models, a relational model is the most popular data model. Relational model is the most popular data model. The relational model is simple. Why it is popular means it is simple and elegant. It looks well and it is very simple to understand. It will be in the form of rows and columns. Any data is represented in the form of rows and columns. And hence, everyone who is a no-ways user, who don't have any technical knowledge, also can understand what is happening. So it is represented in the form of rows and columns, which is called as a relational model. The major advantage of the relational model is simple data representation. Data representation is very simple, easy, even when complex queries can be expressed. Very complex queries can also be expressed in a simple form, and you can get the answers with the help of a relational model. Relational model. This is the most popular model out of all existing models, that is a relational model. Here we make use of two languages. One is a DDL, stands for data definition language. One is DDL, data definition language. Another language called DML, stands for data manipulation language. DDL and DML. Using these two, DDL, data definition languages, and DML, data manipulation languages, we will develop the constructs of the relational model. That is what we do. Yeah. If you observe this relational model, as I told you previously, the data is represented in the form of rows. The horizontal forms are called rows. The horizontal forms are called rows. The horizontal forms are called rows. And the vertical forms are called columns. These are called columns. These are called columns. First column, second column. The vertical forms are called columns, and the horizontal forms are called rows. This is a row. This is a row. This is a row. And the horizontal forms are called rows. The data, entire data is represented in the form of a structured nature, which is called as a relation. This entire stuff we call it as a relation. Example, student ID, name, login, age, and grade. Which grade? You observe here, student ID is a column, name is a column, login is a column, age is a column, age is a column, grade is a column. All these are called as a column, or we call it as an attributes. We call them as either columns or we call them as attributes. The attributes of ER diagram are converted into the columns. You observe carefully the attributes. They are called attributes. Student ID, name, login, age, grade. They are called attributes, or we call them as a columns. Or otherwise, simply we say them as a fields. The fields of relation. This entire stuff is called as a relation. This entire stuff is called as a relation. The horizontal forms, the instance, the data is called tuple. This is called either one row, or we call it as a tuple. You need to remember tuple, T-U-P-L-E, or it is called as a tuple, T-U-P, right? L-E. It is called as a tuple. The horizontal form is called as a row. We can call it as a row, or we can call it as a tuple. It is a row, or you can call it as a tuple. The horizontal form is called row. For example, here 50000 dev, and login is a dev@CS, age is 19, and grade is 3 or 30. Then this is called as a tuple or row. This is one row. second row, third row, fourth row, fifth row, sixth row. There are 6 rows, first row, second row, third row, fourth row, fifth row and sixth row. So totally there are 6 rows. How many columns are there? First column, second column, third column, fourth column, fifth column. 5 columns and 6 rows are there. You can observe here the horizontal forms are called tuples, are called rows, or sometimes they are called as records. Tuples, records or rows we call. This is the example which is being depicted. You can observe here this example, you can see example. Student, the name of relation is student. It contains, you observe this line, student ID of string type. Student ID is of string type. It is not numeric. For example, you take your roll number. Your roll number contains AT, 1A, 00. You contains all that. 580, 100. It is a combination of alphabets and numbers, and hence student ID is of string type. Name is of string type. The second one. This is called domain. Student ID is called field. Listen carefully. Student ID is called field. Field 1. It belongs to string. So it is called D1. Let me say. The field 1 belongs to D1, domain 1. Name, the second field. Let me say it is a field 2. The field 2 is of string type, so it belongs to domain 2. In name, we should store only strings. Login is of string type. Age is of integer. This is called field, it is called domain. This is called field, this is called domain. This is called field, this is the domain of the field. For example, age. In age, what you store? Integer numbers you store. You will not store alphabets. You will store integer numbers. The integer numbers may, student age may lie between 16 to 25, let me say. 16 to 25, that is 2 digits. 2-digit integer number, 16, 1, 6, it is a 2-digit, 25, up to 25, 2, 5, 25. It is a 2-digit integer number. Age is a 2-digit integer number. This is called domain. Integer, 2-digit integer, that is a domain. GPA. GPA is real type. For example, the GPA may be 33.5, 56.4, something like average. Then it is a real number. It is not integer. It is a real number. So this is the domain. So when you observe this, you observe carefully. Student is a name of relation, means the table. The entire table is called student. Student number is of string type. Name is of string type. Login is of string type. Age is of integer type. And GPA is of real type. The GPA, it is of real type. So as I explained you, every field contains some domain values. These are the domain values of string. This is a name, it's the domain values of string. Login is the domain values of string. Age is the domain values of integer. GPA is the domain values of real numbers. It contains all real numbers. So that is what you need to observe. Alright? Now you observe here. Introduction to relational model, as I just now explained. A relational model contains field F1 which belongs to domain 1 and so on. F2 belongs to domain 2. F3 belongs to domain 3. Fn belongs to domain n, where D stands for domain. D1 belongs to domain 1, D2 belongs to domain 1 and Dn belongs to domain n. Dn belongs to domain n. If there are 10 fields, there will be 10 domains. Example, you observe here, student number, let me say numeric, Anukundam. Yes, we assume. Student number, this is a field. This is nothing but it is a field. Right? This is nothing but the domain. It is a numeric. Name, it is a name. It is a character type. Mark 1, numeric. Mark 2, numeric. Mark 3, numeric. Date of joining or date of admission, let me say. Date of joining, it belongs to a date type. When you say date type, here generally it takes DD, MMM, YY. Means day, month, MMM. In SQL, it takes month as MMM. For example, January, JAN, February, FEB. Okay, year. It takes 4-digit year. Year, and year. It takes 4-digit year. This is the domain of date. That is the domain of date. So the general representation in the algebraic form, field 1 belongs to domain 1, field 2 belongs to domain 2, field 3 belongs to domain 3, field n belongs to domain n. Where D1 represents some domain, D2 represents a domain, and so on. Dn represents some domain. It belongs to some domain. Example, you can say student number is a numeric domain. Name is a character domain, that is a strings. Mark 1 is a numeric domain, Mark 2 is a numeric domain, Mark 3 is a numeric domain. Date of joining is a date domain. It belongs to a date domain. So this is how we represent the data in the relational algebra or while expressing the queries of SQL. Now we discuss creating and modifying relations using SQL. Listen carefully. Actually, this comes under laboratory. The laboratory concepts. All this comes under the laboratory concepts. I take laboratory for you. After a few days, I commence the laboratories. Online demonstration I give in SQL. How to create a table in SQL. Now I am talking about SQL, structured query language, that is Oracle. After installing Oracle, I'll show you practical demonstration, don't get worried. After installing Oracle, suppose I want to store the details of student. Listen carefully. I want to store the details of student. Student ID, name, login, age, and GPA. I want to store these details. There's nothing but average. Then first schema, structure is to be created like this. This structure is to be created. Student ID, name, login, age, and GPA. This structure is to be created. Once again, I am repeating. I want to store the details of student. So first the schema is to be created. The structure is to be created like this. How to create this structure? First the structure is to be created like this. How to create the structure? There is a command called create table command. There is a command called create table command. With the create table command, you can create the structure. This is a DDL statement. This statement is called DDL, data definition language statement. DDL statement, data definition language statement. Create table students. So I want a table by named students. And it should contain student ID belongs to character of 20. Student ID is character of 20. Name, character of 30. Name, character of 30 means you can store maximum 30 characters. Login of the student, character of 20. This is the login of student. Age is an integer type. And the GPA, it is a real type. So if you type a command like this on system in Oracle, create table students. A table by named students gets created and it contains student ID, name, login, age, and GPA. Student ID, name, login, age, and GPA. In student ID, you can store all characters, maximum 20 characters. Char of 20 means maximum 20 characters you can store. Name is character 30. You can store maximum 30 characters. Login is character 20. You can store maximum 20 characters. Age is integer. You can store integer numbers only, not real numbers. Age is integer. It can store only integer numbers. GPA, it is a real type. GPA is a real type. Real type means fractions. It supports fractions. If this command is given, automatically in your disk, this sort of table will be created. The schema will be created. The structure will be created like this. As it is creating the structure, it is a DDL statement, stands for data definition language. DDL stands for data definition language. Just a minute, you please go through this statement. You try to memorize this. Create table name. Here any table name, a list of attributes and their domains. List of attributes and their domains is to be given. Open bracket, close bracket, followed by semicolon. open bracket, close the bracket, semicolon. Here comma, 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 comma. Please, 1 minute, you go through this statement, you try to mug it up by heart, understand. Please don't get worried about the uppercase or lowercase. Even if you put uppercase or lowercase, it doesn't matter. It is not case sensitive in the context of fields. It is not case sensitive. Here I use small I, small I. Here your capital. That's what you mean to say, right? Don't get worried and bothered about this. It is not case sensitive regarding attributes context. I'll demonstrate that. In C language, Java, it is a case sensitive. It is not case sensitive. I appreciate your observation, and that is a valid point. It is not case sensitive. Right. I'm proceeding to the next concept of inserting. After creating, slowly I want to store the data. In the previous case, I created a table. Now inside the table, I want to store the data. How I am storing? You observe here. Insert into students. This is the table name of table. Insert is a command. Insert into students, into the table students. Insert into students. I want to store, insert into these fields: SID, name, login, age and GPA. Into these fields I want to store. The list of fields you need to write: SID, name, login, age, and into GPA I want to store. What values you want to store? You need to specify values. What are those values you want to store? Values. Give the value student ID. This goes to student ID. The name of the student Smith, that goes to name. Smith at the rate of E, it goes to login. 18 it goes to age, and 3.2 goes to GPA. That will be inserted like this inside the disk. If you give this command, the data will be recorded like this. Similarly, for the next student, again I should type insert into students. Student ID, name, login, age and GPA. Values. You give some other values: 7,000, Prem at the rate of CSE, and some age is 19 years, and GPA is 4.2. That gets inserted. Again you type insert into students, student ID, name, login, age and GPA. Values: 8,000, Kumar at the rate of CSE, comma, 16 years, and 2.2 is a GPA. That will be inserted. All this will be inserted into the table. In the previous case, you came to know how to create a table. First, we need to create the table. After creating the table, you need to create the table. After creating the table, empty table got created. Now we need to store the values into that. How to store the values? With the help of insert command. Insert into table name. The table name is students. The column names, I am specifying the column names. These are optional, not compulsory. The specifying column names is not compulsory. Okay, right. Insert into students these column names. Values, what values you want to store into these columns, you specify. That's all these values will be stored into the disk. Just 1 minute, you please go through this statement. Try to by heart, try to memorize this statement. Right, hope you memorized this command. Now you know how to create the table, how to insert the values into the table. Let us progress further. Deleting. Now I want to delete. So this is the table. In this table, let me say you're having Smith, you're having Prem. There is a data of Smith, there is a data of Prem. There are two rows in the table. Let me say the name of the table is students. The table name is students. The name of the table is students, right? It is students table. It is students table. In this students table, you are having some data. Now I don't want Smith. Previously I inserted, but now I don't want. Then you should use a DML command called DML command. Because you are working with instance data, you want to remove the data. I want to delete. Delete from table name, delete from students. The students is represented by S. S is called alias. S is representing students. S is representing students table, where S dot name is Smith. Means S means students. In students table, if name is Smith, S dot name in students table, S means it is representing students. In students name is Smith, you delete. Delete from students. Delete from students. Delete from students. From students you delete. Where S dot name, S means students. Students name. S means students. In students, S dot name is Smith. Whose name is Smith? 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 You delete it. That's all. So this is before deletion. After deletion, you observe here. After deletion, you observe here. There is only Prem. There is no Smith. That got deleted. Delete from students, from the student table, from the students table. Delete from students. Yes. Where S dot name is Smith, means student's name is Smith, where name is equals to Smith. That will be deleted. And hence this Smith row will be deleted and Prem row will be there. And hence there is a Prem row. You don't have Smith row. You came to know how to create a table, how to insert a row, how to delete a row. Insert a row, how to remove the row. You are able to know this. Just a minute, you please go through this. Try to memorize that delete statement.
Hello, sir.
Yeah.
Sir, ఇప్పుడు నేను 5 columns క్రియేట్ చేసి 4 headings ఇస్తే ఎర్రర్ వస్తుందా సార్?
Yes. Error.
సార్
Yeah.
సార్ ఇప్పుడు స్మిత్ అనేది డిలీట్ చేస్తే రో మొత్తం అవుతుందా సార్?
Complete row will be deleted. Complete row.
సార్ ఇప్పుడు నాకు అదొక్క నేమ్ ఒక్కడే డిలీట్ అవ్వాలంటే?
I'll tell you the command update. With update you can do that. Only that name can be deleted. Only 2 fields can be deleted. Part of row can be deleted. You can do that with update, not with delete. When you apply delete, the entire row will be deleted. The Smith's complete data will be deleted. Complete data. I hope all the students you're following. Dear students, you are learning very, very important concept which is helpful for your life. For the settlement of your life. There are a number of subjects in B.Tech. I don't discourage all the subjects. I don't discourage. Every subject is having its own importance. But there will be some subjects to get degree. There will be certain subjects for existence, for life, for job purpose. And being computer science students, you need to focus much on back end. This is a DBMS. It is a back end, Oracle. And also go for the front end. In the second year, you're having the front end is Java. That is the most important subject. You are having the wonderful subjects, Java and DBMS. These two are the most stunning subjects of your second year. You are so fortunate that these two subjects came in the second year 2-1 itself. So focus well. And these two are scoring subjects also. The marks, very simple. DBMS is a very simple subject. You can score marks well. I'm proceeding to the next one. Modifying. Some modification activity. I want to perform some modification activity. And coming to this modification activity, modifying a relation. For example, this is the data. Once you observe this relation. Let me say this is a students relation. The name of the table is students. Okay, it is a students table. It is a students table. It seems it is a students table. Let us think it is a students table. You are having this data. I want to increase age by 1. You listen carefully. I want to increase age by 1. I want to decrease GPA, that is average, by 1. Age is to be increased by 1. age is to be increased by 1, and GPA I want to decrease by. How I am doing? That is modifications I am doing. There are some rows here. There are some tuples here. Smith age is 18 years, 3.2 GPA. Prem age is 19 and 4.1 is a GPA. Update students. Update is a command. It is a DML command. As you are working with the instance, it is a DML command. It is a DML command. Update is a DML command. Insert is a DML command. Delete is a DML command. Update is a DML command. Create is a DDL command because the schema, it creates the structure. Create is a DDL command. Update students. Set age equals to age plus 1. Set age equals to age plus 1. You observe here I am using alias. This is called alias. The student is represented by S. S dot age means student's age is increased by 1 and student's GPA is decreased by 1. For whom? For whom I am doing 5368. Whose student ID is 5368. You observe here, previously the age is 18. After updation, age became 19. You observe the point, age became 19. The GPA is previously 3.2, now it became 2.2. The age got increased by 1 and GPA got decreased by 1. You listen the point carefully. Update students. The name of the relation is student. The name of the table is students. Updates. Age equals to age plus 1. GPA equals to GPA minus 1. Age is increased by 1. GPA is decreased by 1. Age is increased by 1. GPA is decreased by 1. Where student ID is 53688. 53688. For this student only, not for all. Only for this student. Age got increased by 1. That became 19. Previously age is 18. Now it became 19. GPA previously 3.2. Now it became 2.2. That got decreased. Right? This is regarding update. You can do modifications. Wherever required, you can do modifications. You can increase, you can decrease, you can delete. By null value, you can put some null values and you can delete that. I'll show you with the practical demonstrations. I will show you. For time being, once you go through this update command for a minute, please. Right. I'm proceeding. So you came to know how to create a table, how to insert. Creating table is a DDL. How to insert the values. When you are dealing with values, that is instance, it is a DML. How to insert values, how to delete the values, how to modify the values. So you are able to do everything. Creating a table, you know, inserting values, you know, deleting the values, modifying the values, right? So now let us have a discussion on integrity constraints over relations. Integrity constraints over relations. In short, I am calling it as an IC, stands for integrity constraints. As I told you previously, suppose if I enter age of the student, the age of student should lie between 16 years to 26 years. This is a boundary I am fixing. The age column should have age in between 16 years to 26 years. Then see here, age column. I'll enforce an integrity constraint here. For age, I'll enforce an integrity constraint. IC stands for integrity constraints. I'll say the minimum age can be 16 years and the maximum age can be up to 26 years, let me say. The maximum age can be up to 26 years. This is called integrity constraint. Suppose if I am trying to push anyway age of 30 years, it will not accept. It shoots error. It will not be inserted into the table. That is called integrity constraints. You are having different types of integrity constraints. Primary key, unique, not null, default, foreign key, referential integrity constraints. Referential integrity constraints, you are having number of integrity constraints. We discussed those integrity constraints. That's what he says. So it supports, our SQL supports IC, stands for integrity constraints on the database. The database enforces integrity constraints in that it permits only legal instances. It permits only legal instances. So if I say 16 to 26 is legal for me, I accept. Above that or below that, I'm not ready to accept. That is illegal. For example, gender. There is a column gender. Gender can be either male or female. So I put an integrity constraint that the gender can be either M or F. If anything other than this, if it is entered, it will not accept. Your table will not accept. This is called integrity constraint. You are enforcing the integrity constraints. Right? The integrity constraints are specified and enforced at different times. That is when DBA and end users define the database scheme. While creating the schema itself by DBA, database administrator, by database administrator, while creating that database schema, he or she specifies the integrity constraints. When these integrity constraints are to be specified, they are to be specified when you are creating the structure, the schema by DBA. That is one point. When database application is running, the DBA checks for the violation and disallows the changes of the data that violates the specific integrity constraints. So the integrity constraints are enforced or specified at the time of table creation. And there is also possibility after table creation also, if at all you feel something adding some extra integrity constraints, you can do that with alter table command. There is a command called alter table command. I'll demonstrate that. With the help of alter table command, you can alter the tables. You can alter the constraints. You can add constraints, extra integrity constraints you can add. Either with the help of create table, while creating the table you can do that, or alter table command is there. There is a command called alter table. You need to memorize alter table. With the help of alter table command also, you can add the integrity constraints. And the DBA will be checking while executing the programs, the application programs, while running the application programs, whether constraints are obeying or violating. If they are violating, they will disallow. If they are violating, they will disallow the data. For example, employee salary can be from 20,000 to 60,000, let me say. I specified a constraint that 20,000 is minimum, 60,000 is a maximum. If employee salary is entered as 8,000, it should bounce, it should not accept. So he will disallow the DBA by enforcing the integrity constraints. He will disallow the violating concepts. You observe this? You observe this example. I'm creating a table. Create table students. Create table students. You observe this? Create table students. Student ID, student name. I'm creating a table. Students, student ID, student name, login, age, GPA. You observe this carefully. All of you observe this carefully. Unique, name, age. Unique, name, age. It implies name and age should be unique in nature. Name and age, this combination should be unique in nature. For example, name may get duplicated, age may get duplicated, but this combination should not be duplicated. That's the meaning. Unique means, for example, I entered student name is Prem, age is 16. Good. The another student name is also Prem. There is that possibility. Another student also can have Prem. His name is Prem, and if I enter age as 18, it will accept. Suppose if I enter another student as Prem and age is 16, it will not accept. This combination should be unique, I am specifying. Means name and age, name can be duplicated, age can be duplicated, but this combination should not be duplicated. That's the meaning. I repeat again. Name can be duplicated, age can be duplicated, but this combination should not be duplicated. For example, if I enter Prem, age 16, good, it will accept. Prem 18, it will accept. Prem 20, it will accept. If I enter Prem 16, it will not accept. Because this combination should be unique in nature. This is called unique constraint. This is called unique constraint. The constraint student key, primary key SID. You observe here. Here primary key. I am using a constraint called primary key. Primary key is constraint. Unique is a constraint. Primary key is a constraint. Primary key means it should be not null and unique in nature. The meaning of primary key is not null and unique. It is not null It is not null, means definitely there should be a value. Not null. Not null means definitely it should contain some value. And that value should be unique in nature. It should be unique in nature. Unique in nature means no duplicates. It should be unique in nature. It should be unique in nature. It should not be duplicated. It should not be duplicated. That's the thing, primary key. For example, I entered 101, good. 102, good, it will accept. 103, good. If I enter 102, it bounces. Because the primary key, the meaning of primary key is unique. It should be unique in nature, no duplicates, and there should be value, not null. I should not leave it blank. It is not null and unique in nature. That's what is a primary key. So this is how we impose constraints on the table. Once you observe this table, create table students. I'm creating a table called students, which contains student ID, name, login, age, GPA. And here I'm specifying a constraint, unique. Name and age are unique in nature. This combination should be unique in nature. And student ID is a primary key. Primary key means it is a not null and unique. The student ID should not be duplicated. You take your example, your own example, your roll numbers will not be duplicated. If duplicate value is entered, it should not accept. The system should bounce with an error that this roll number is allotted for someone else. So that is the meaning. Primary key SID means student ID should not be null. It should not be null. There should be some value and it should be unique in nature. It should be unique in nature means no duplicates. That's the meaning. Just a minute. You please go through the slide.
సార్
Yeah.
మీరు డూప్లికేట్స్ ఉండకూడదు అన్నారు కదా సార్.
Yeah.
సార్ ఒకవేళ ప్రేమ్ అనే నేమ్ అండ్ సేమ్ ఏజ్ ఇద్దరు ఉంటే ఏం చేయాలి సార్?
Yeah, అప్పుడు యూనిక్ తీసేసేయాలి. If you remove this constraint, then duplicates are allowed. Suppose you are very particular, it should not have duplicates, then you need to have this. If you remove this statement, duplicates are allowed, right? If you don't want duplicates like that, you put this constraint. That depends upon your wish. Primary key constraint means value should be there. Definitely there should be value. And that value should not be duplicate value. For example, this is the table. Let me say this is the table. This is the table. Here I entered name. Some name I entered. Here I entered some total marks. Some marks I entered, 90 marks. I entered some age, 16, age is 16 I entered. But I am not entering student number. It will not accept. I am not entering student ID. If I don't enter student ID, if I leave it blank, it shoots an error. The primary key means student ID should not be null. Not null means definitely there should be a value. Definitely there should be a value. And the given value should not be duplicated. Suppose there is another student with roll number 2. I am giving the same roll number 2, it will not accept. So the primary key meaning is the student ID is not null. Not null means definitely there should be value and that should be a unique value. Unique value means no duplicates. That's the meaning of primary key. Once again, primary key means it is not null and unique in nature. Not null means definitely value should be there. Unique in nature means no duplicates. That's the meaning of primary key.
Sir?
Yeah?
Sir, ఒకసారి లాస్ట్ బట్ వన్ పాయింట్ ఎక్స్ప్లెయిన్ చేస్తారా సార్?
What is that last but one point? This is
The
definition of the primary key illustrates how to use name a constraint by preceding it constraint name. You observe here primary key SID I am saying. Before that I am using a reserved word called constraint. I am using a reserved word called constraint. Reserved word. Constraint is a reserved word. Followed by here you can give any name. Constraint name. Here you can give any name. You can give any name as you wish. I am giving name as a student keys. So I practically demonstrate while explaining SQL statements. So for time being, you don't get worried about this portion. I'll demonstrate. In our laboratory, while explaining practical demonstrations, I give you constraint, that is a reserved word, followed by any name. This is called constraint name. Constraint name. What is the purpose of this? I'll demonstrate in laboratory. Dear students, I am proceeding. Right. There is a concept called foreign key references. Let us have a discussion on foreign key references. And coming to this foreign key references, as I told you previously, we discussed about this foreign key. For example, there is a table like this: student number, student ID, name and total. There is already a table. The name of the table is students. Let us think the name of the table is students. Okay. The name of the table is students. It is students. The name of the table is students. In this students, you are having student IDs, name and total. Now I want to create another table called enrolled. The name of the table is enrolled. This is the table enrolled. I want to create a table called enrolled. Which student enrolled for which course ID? Course ID. CID is a course ID. 101 enrolled for course ID 10 with a grading points of 5. And he got 5 points in that course. 101 enrolled for course ID 10 and he got 5 points. Yes, 101 is there. Here you are having 101. And hence here the 101, 10 and 5 are accepted. Suppose in this table I am trying to store 105 enrolled for course ID 20. It should not accept. This is wrong. It should not accept. Why? 105 student we don't have. Only these students can enroll. 105 enrolled for course number 20 I am saying. But this is wrong statement. Why it is a wrong statement? We don't have a student 105. And hence foreign key references means while storing data into this table, you should refer another table for the existing of the value. 101 is there? Yes. And hence you accept. This is right. 105 is there? You first check it here. No. It should bounce. It should not accept. This is called referential integrity constraints. How this is being done using SQL? You observe here how this is being done using SQL. Create table enrolled. This table is enrolled table. Create table enrolled with student ID, CID, course ID, grade, student ID, course ID, grade. Primary key is student ID and course ID. These two combination I am putting it as a course primary key. Primary key means this combination should not get duplicated. The combination should not be duplicated. That is the primary key. Foreign key references students. Foreign key references students. Now you observe carefully. Foreign key references students. What does it mean? Foreign key references student. Means foreign key is student ID. This is the foreign key. It should refer students table. It refers a student table. Foreign key is student ID. This is the student ID. References, it should refer which table? Students table. It refers this table. So here 101, 101 is there. So it is accepted. 105, you don't have 105, it is not accepting. It is shooting error. As 105 is not there, it is not accepting, it is shooting error. Please go through this. Thus, this is nothing but the referential integrity constraints. The outcomes of this class is the relational model. We discussed about the columns, tables and tuples. We had a discussion on the columns, tuples, what is meant by a relational model. That's what we discussed. How to create a table, how to insert the values, what is the deletion values, modifying the values, and we discussed about the integrity constraints. This is what we covered in this class. Dear students, bye bye. Have a wonderful day.